Okay, for today, we're going to discuss buffer and buffering capacity. In chemistry, a buffer solution is essential for resisting changes in pH when small amounts of acid or base are added. Buffers are crucial in various chemical and biological experiments because many reactions require a constant pH to proceed correctly. Today, we will discuss what buffers are and how they work. What is a buffer? A buffer is an aqueous solution that resists significant changes in pH upon the addition of small amounts of acid or alkali. It typically consists of a weak acid and its conjugate base, or a weak base and its conjugate acid. By neutralizing added acids, H plus ions, or bases, OH negative ions, buffers maintain a moderate pH level in a solution. How buffers works? Buffers neutralize added acid or bases to maintain a stable pH. For example, in a buffer containing ammonia and its conjugate acid ammonium, the addition of a strong acid like HCl causes the NH3 to consume the extra H positive ions, forming NH4 positive and preventing a significant pH change. Similarly, if a strong base like sodium hydroxide is added, the ammonium ion donates a proton to neutralize the base, minimizing pH changes. Buffering capacity. Buffering capacity refers to the amount of acid or base a buffer can neutralize before significant pH changes occur. The capacity of a buffer depends on the concentration of the weak acid and its conjugate base. Higher concentration of a buffer components increase the buffering capacity. Once the buffer's capacity is exceeded, the pH will change dramatically. Types of buffers. Buffers can be classified as acidic or alkaline. Acidic buffers with a pH below 7 are made from a weak acid and its salt, while alkaline buffers with a pH above 7 are made from a weak base and its salt. Importance of buffers. Buffers are vital in both natural and laboratory settings. For instance, the bicarbonate buffering system regulates the pH of blood in a human body. In labs, buffer creates a stable pH environments.
Let's take a look at how pure water, 0.1 molar buffer, and 1 molar buffer resist a change in pH. For this particular indicator, blue is neutral and green and yellow are acidic. I have some 6 molar HCl here. Let's add a drop to our pure water. Just one drop of 6 molar HCl turns that acidic. Now let's take a look at our 0.1 molar buffer. That's a lot more acid than I added to the water. Now let's take a look at the 1 molar buffer. That's about the same amount I added to the 0.1 molar buffer. But you can see the color hasn't changed that much. The 1 molar buffer has a higher buffering capacity than the 0.1 molar buffer.